So, I'm Dora. Thank you for that lovely introduction, Jana. I'm a web developer and I work for the Financial Times, which is a global news organization. And I started my career at the FT almost 2 years ago, working on our flagship news website, which is ft.com. And since I went on to tech lead the GDPR project for ft.com, which was great fun. And I now work in internal products. I've moved completely away from the front end and anything that users can see. I'm also a digital nomad, so I fell in love with traveling last year on a conference circuit, and I'm actually working from Russia for pretty much the next 2 months. It's been great. I tech lead 3 projects at the moment, and I'm really proud to say that there's 2 all-female teams amongst these projects, and the engineering team is 70% female. And my immediate colleagues, the engineers, are actually not all white and not all under 30, which is very rare in the industry. And I'm super proud to put that on the slide today because we're celebrating International Women's Day. It's actually, I'm super passionate about diversity and making people understand that it's a problem, why it's a problem in our industry. So I spent a lot of last year thinking and writing and talking about diversity. And in fact, I even went to Novosibirsk to an amazing conference, DEFA Siberia. And I spoke there about how to make our industry more inclusive, more friendly. And since then, I've started thinking about what does our industry produce? Can we make that? Can we make the fruit of our work more inclusive? How are we going to do that? What is the fruit of our work? It's the internet. This is a great one if you have relatives over 80 who asks you what you do for a living. So I build the internet. Any web developers here build the internet in our own way. We make a contribution to this. And I want to build the good internet, right? A more inclusive internet. What is the good internet? There's a few factors that contribute to what makes the internet good. There are ecological factors that are not really in our control. They're more to do with government, with regulation, with policy. There are things like open data, infrastructure, pricing, availability, open knowledge. There are also ethical factors that can make the internet good. I keep forgetting the receivers over there. So things like neutrality and freedom of expression and the quality of what we put out there on the internet are very important, and they're worthy of a talk in their own. What I want to talk about today is the contribution we can all make, and it is good internet engineering. Things like security, accessibility, and performance should be part of our daily workflows. We should absolutely care about those. And today specifically, I want to talk about performance. When the slides change. Okay. Nope. How are we doing on performance in general? So you might think that, okay, this is the modern internet. We have iPhones, we have great devices. Everything is like faster than it was a few years ago when we had dial-up modems. But I've looked at the HTTP archive stats for the past 2 years, which is as long as I've been a web developer. And it's actually pretty bad. So the time, the perception of slow first contentful paint is increasing. So there are a lot more websites out there today that take over 2.5 seconds to display anything useful. And that's a long time. First paint as well. So that's the first thing that appears, the first pixel, the first thing that the server responds and puts on the client side. That's on the up as well, the slowness. So we're not getting any more performant. In fact, we're getting much worse at web performance. There is more bloat. We have all these fancy frameworks that mean that our and beautiful images and videos and Instagram and stuff. So our transfer size is actually on the up. Our DOM is getting increasingly more complex. Our markup is just very hard to parse, so the browser engineers have to keep up with it increasingly in a more competitive way. And we've forgotten the good stuff we used to do with web performance, things like a proper font loading strategy. So a flash of invisible text is on the rise. People aren't lazy loading images anymore, so like, why? Why should you care about performance since, you know, I have an iPhone and it's a microcomputer and it's pretty fast at parsing these things. And I think a great way to think about a lot of things is in terms of money. So Tim Kadlec, who's prominent in the web performance community, built this thing called whatdoesmywebsitecost.com. I've taken the front page of our competitor, The Guardian. The FT is also similar in transfer size. And I've run it through whatdoesmysitecost.com. And this is a representation of the cost as the percentage of individual GDP. And it is price parity with the British pound, in my case. So, while as for me, if I want to browse The Guardian and I'm roaming in Russia, you know, if I want to read the news and I'm on a budget, maybe I won't have my second latte. For someone in Nigeria, they won't have anything to feed their family with if they read the news. So that's why you should care about web performance. It matters, and web performance in itself makes everything more inclusive. Not caring about web performance, it can exclude swathes of people, low-power devices, countries where data is expensive. We should absolutely put more effort into these things. And it's fair to start in my own back garden with some notes on ft.com. I'll start with some history. So before my time, ft.com was codename Falcon. So we have codenames for engineering projects. It looked a little bit like that. It's much more swish these days. And this is codename Next. Next was launched the year I joined the FT, actually. And when it was launched, and for most of 2017, it was actually the fastest site in publishing and news, and one of the fastest sites on the internet. And the web performance stuff was cutting edge for ft.com. It got me really, really excited. The things that we did are now copied by other news publishers. So I want to take you through some of those tricks. I'm going to start with what happens when you visit ft.com. So this is kind of a rough diagram of what happens. I'm going to talk about the top 3 things, and then I'll go into more detail about the bottom bit as well. So I'll start with our DNS, which is like the phone book of the internet. Every request goes via our DNS. We use Dyn, and our main 2 domains are ft.com, which is called the apex domain, and then the www subdomain. And on Dyn, we have one CNAME record for the subdomain, and that basically just delegates the DNS routing to our content delivery network, to which I'll get to in a bit. And of course, you can't have CNAMEs on an apex domain, so that has 4 A records that also point to the CDN, which is a little bit unusual, because CDN, for most people, is something that serves their jQuery or their images. As a matter of fact, we serve the whole of ft.com through our CDN, Fastly. There are many reasons we do that. First of all, Fastly maintains servers in over 50 locations around the world. Our most premium apps only have 2 backends, one in the States, one in Europe. So this helps us tremendously. And Fastly uses border gateway protocol and anycast routing. So anycast routing is where datagrams from a single sender get routed to the most optimal node based on whatever you want it to. I think in our case it's something like how busy the node is, how much it costs, what the latency is to get there. It's just an optimization function. It's really brilliant. And it routes requests to the nearest point of presence, so we can avoid unplanned outages and planned maintenance, and have planned maintenance. Now, the Fastly stack is two things. There's an HTTP proxy, which is H2O, and this is like a super speedy H2 server. We don't use that. I'll get to why in a second. That handles TLS terminations. And Varnish, which is a reverse HTTP proxy. A reverse HTTP proxy is basically just looks like a normal server in the eyes of a client. And Varnish is a caching server, and we leverage this very, very heavily. Now, the reason we don't use H2O, by the way, is because we need to support Internet Explorer 10, so we need to care about TLS 1.0 and 1.1. On to Varnish. Varnish is actually brilliant. It can be scary to a lot of people, but the whole workflow for configuring Varnish, and use something called VCL, Varnish Configuration Language, is a finite state machine, and each state is conceptualized and implemented as a subroutine. So you've got the subroutines start with like VCL underscore, that's a reserved keyword. So you've got receive, hash, fetch, deliver, which is delivering the content to the client. So there's a lot of logic in Varnish that Fastly enables us to hook onto by writing our own custom VCL. And this is very valuable for our caching strategy. And I'll get to some of the things we do in VCL in a bit. It is very powerful to be able to have this access, this fine-grained access to the subroutines in a cache. And we do lots of things on Fastly, and it serves us a lot of infrastructure and processing power. So for example, this snippet of code, it's in VCL deliver, which is the last subroutine before something gets served to the client. This is an example of how we set the HSDS policy for the whole of ft.com. And we do that so that an app that lives somewhere on ft.com that may be sending a strict transport security header doesn't accidentally break the whole thing. We have lots of stuff like that. Our WAF stuff, Web Application Firewall, also lives on a CDN. Yeah. And the thing that enables a lot of the magic on the CDN is the black box of magic called Preflight. Now, Preflight is a task runner that supports asynchronous and concurrent tasks. And it's written in Node. It's actually no big deal. It should probably be open source. We wrote it ourselves. And what it does, it just takes the request, goes off to various places and gets information about requests. So there are various APIs, like does the user have access to the content they're trying to see? Do they need to see the paywall? In which country are they? Is this a vanity URL? And do we need to fetch like a different content hash for this? It does a lot of work based on the incoming request headers. And then it comes out with a neat list of much fewer request headers that are sanitized and sends them back to Varnish. And this all happens in VCL receive. So we pull Preflight, we send a bunch of headers, and like you can cache on user agent, you can cache on someone's cookie. It would be like really tough. It would be a lot of fragmentation. What we then do is just take the headers from Preflight, restart the whole VCL workflow, and serve the user's content based on the fragmentation of the much fewer headers from Preflight. So this is a lot of magic that is actually quite simple to implement with the setup we have. There's one catch though. So Fastly stores 200 variations of an object, like a document or a fragment or a root. And this is the combination of headers that we then need to vary on. So imagine like things that are unique per user. We can't possibly vary on that. That's why we have Preflight. Preflight separates the users very nicely into cohorts based on the responses from various APIs, which is great for caching. And this setup enables us to have a cache hit ratio of 90%. So like if we have a spike of 9 million requests, only about 900,000 will hit our servers, which is great and much cheaper. And then we're really careful about serving stale content as well. So we have no problem serving stale content on cache revalidate when we hit the max age for an item in a cache. We also serve stale content if a backend errors, and that gives us more time to fix it. And the user won't see a degradation. This is what a typical request looks like. So come in via Fastly. We have a router that pulls a service registry, and then you get to an app based on your route. FT.com is actually made up of over 100 independent microservices. And it takes a special kind of team setup to build that. It takes a special kind of philosophy. When we started building the new FT.com, we kind of had to change how we were doing things. So here are some paradigms about how you build apps, products, web apps in our case. So we have a monolith. One engineering team deals backend, frontend, data store. This was the old FT.com Falcon. We can have backend and frontend. So you have the frontend team working across the frontend and various backend teams and DevOps working together on a backend and data store. You can have the microservices, which is a newer model. You can have the front end and then some sort of aggregation layer that pulls separate services. What we do is even more granular. It's called micro front end. So you have various feature teams. You'll have people working on a paywall, people working on an article page. Those are separate teams, separate apps, and they handle everything they need. They will build their data stores. They will do their front end. And the way we make FT.com still look cohesive is we have a shared component library that is unified and well-maintained and of high quality. Then there's an element in our culture that enables us to be a little bit more agile and to build with these micro front ends. So mistakes happen, and you can choose to either make them harder to make, which is, you add lots of environments, you add QA testers, nothing makes it in production unless it's been signed off by the tech lead, etc., or easier to fix. Because our mission, when we wanted to move from like monthly weekend releases to something a little bit better. So the mission with the new FT.com was to make it easy to release good quality software quickly, frequently, and with confidence. So merge to master, if the test passes, is deploy in our case, which is kind of scary, but we have a few things to mitigate. We wrap every feature, we encapsulate it, we wrap it in a feature flag. So if it breaks production, we can just turn it off in a central place. Every feature also expires so that we don't get a lot of tech debt. The standard life cycle is 3 months, and then the product owner has to go and argue why we still need an article page. I'm exaggerating, but smaller features, it's useful to have them die off after a while. They get turned off automatically if no one argues in their favor. We also have a common stack, common tooling, common infrastructure. Most of our stuff is Heroku. Everything is JavaScript. And we have shared tooling across all the teams, making our work easier, making our work possible. And the teams are services, so if they need to collaborate, they negotiate service level agreements between themselves. It's like a free market economy running in our department. We don't have QA, we do our own DevOps. Why? Why is this not a pain? Because we have a lot of shared tooling. And we've tried to bake in this concern for performance from the beginning in our tooling, in our philosophy, in our culture. Server-side is a case of process and budgeting. And it is very easy to observe, because if you have some monitoring, you can look at timeouts, you can look at how long it takes for a response to happen, etc. But microservices are inherently bottlenecks. This is what pre-flight actually looks like. There's a lot of downstream dependencies. If something is slow somewhere, the whole thing is slow. So we have something called performance budgets. If something is slow and it overruns the performance budgets, that's a timeout. We don't care about that, and we degrade gracefully. We also have something called microservice whack-a-mole. And it's a term coined by a friend of mine. So you look at your monitoring dashboard, you find whatever's slowest, and then you whack it, so you optimize it using whatever creative ways you want to optimize performance. And then you find the next thing that's slow, and you keep going until you run out of creativity. And it's really fun. So I wanted to give you an example. This is one of the first things I did on ft.com. I tried to optimize the paywall. Now, the paywall is super important. That's how we make money. It is, and it has over, like thousands of variations. We might serve someone a special paywall because they're coming from a special IP where we have a deal for them. This is how a lot of our corporate deals work. So it's hard to find a single way to optimize it because there are so many downstream dependencies that we pull. And it's also kind of a critical service, so it should absolutely be faster if we can make it faster. It's a single point of failure for conversion, so handle with care. This is what we did. Thought about geography first, because of how our teams work, some of the backends had an AWS gateway in front of them, and the latency from AWS gateway to the box where the service was stored was actually significant enough. So we went to that team, bought them coffee, and said, can you give us access to your load balancer, which is on the box, rather than the gateway? And they're like, yeah. And then we had a graph like this, which was amazing. Then we realized that we had a bug in the routing layer on the CDN, meaning that requests from the US were doing a global round trip to London. So we fixed that. That's just silly. Then we managed the connection pool. So in Node, you can do something called keep alive that just keeps that connection pool open, and you can reuse it so you have less overhead and less latency. And it's very simple to implement. And it can slash your latency in half. Then we looked at we got even more obsessed with this performance optimization, and we wanted to minimize the request overhead. So we wanted to we built a GraphQL layer on top of these APIs and then cached the response from the GraphQL layer, which also made a huge difference. And we refined our caching strategy over and over and over again. We made it pretty fast. It was great. Client side, on the other hand, is not a case of budgeting and process. It's a case of blood, sweat, and tears, because it's very hard to observe what happens with performance degradations on a client side. So we had a set of principles. We're like, okay, we have to reuse assets between visits, between page views, on the same visit, so as much as possible. Then we have to keep things supple by using responsive images, or transpiling less, or having dynamic polyfills, using things like resource hints. So basically a shopping list of web performance best practices. Wrote everything in vanilla.js, avoiding frameworks, so we have none of that overhead. But hey, there's 10 front ends. How can you automate performance across 10 teams? By building a perf thing that does everything under the sun. So it decides on some common dependencies across the front ends. It is the build tool that does code splitting, that does all the performance optimizations. It's got the templates that make ft.com look like ft.com. It does a lot of stuff. It's called NUI, and it's open source, and you can actually see it. And it does some really clever stuff, like cutting the mustard. Basically, ft.com has to work without JavaScript. And also, because we know that it works without JavaScript, everything that's under a certain level of browser support policy, we just degrade to that core experience, no JavaScript. And it helps us deliver news quickly to people without bloating their connection. NUI also does the polyfilling. So we maintain a polyfill service, and it actually reads the user agent string and serves back the JavaScript that is needed to support that performance based on the user. So NUI also does this for us. And it keeps bundle sizes in check. In the same way that we have performance budgets for backends, we kind of have, hey, you've put too much CSS in, be careful. But they're just warnings. And it also does stuff like inlining critical path CSS. So anything that is above the fold, above the end of your screen when you load a page, is inlined. It's straight in the DOM when it comes back from the server, so that is a huge performance improvement. And it also does resource hints, which could be a talk in themselves, things like preload, prefetch, and so on. And it also stores some third-party scripts, which I'm not very proud of, but whatever. Everybody hates it. Everybody hates it because it does so much stuff that very few people actually understand it. It breaks all the time because no one wants to touch it. And it's just inextricable from our work because it's so indispensable because we've built too much cleverness in it. So what's our solution? Something called Project Anvil. Let's build a new perf thing. Go away from bundles. We're now thinking about ES modules, and new browser engines and new V8 are super optimized for these things. So it could reduce the JavaScript running time by quite a lot. And we want to do this kind of thing, like we still do the bundling and the code splitting, but we also leave the ES modules, and we only fall back on a bundle and send it down the pipe if the browser doesn't support it. But there's some roadblocks. Like, we have a lot of dependencies that don't ship ESM on the front end. And the resource hints are server side. So the server doesn't know, because preflight strips the user agent out. The server doesn't know what kind of browser you have and whether it should give you the ES modules or the bundle. So I did a little experiment, make 2 bundles. So the normal bundle that we had and one that is transpiled much less to like ES6. Sniff the user agent at the CDN, and then cut the mustard twice. So you have the like minimally transpiled, the normal bundle, and the core experience, which is far too much magic, but it was fun. So are we fast? No, we're not fast. We're kind of slow, actually. We used to be at the top of that article performance leaderboard maintained by Hearst. We're now number 8. Why is that? Should I be ashamed? No, because performance is a process and it's very hard to get right. And it's usually a one-shot optimization rather than continuous. And we need to move more towards continuous optimization. We need to put performance in a place where it's visible and observable, like on CI. There's some tools to do that. We can even do data-driven optimizations. There are tools these days that look at user journeys and decide what assets you should serve for most users. Things like Gas.js. And avoiding micro-optimization. So measure everything and make sure you have a problem before you start optimizing, so you don't waste a lot of time on little things that don't have a lot of effect, because it's very easy to get obsessed about these things. So that's pretty much it. I have some takeaways. How we choose to build complex things is very, very important from the beginning. These choices won't always necessarily be good for performance. So you have to find compromises between this, and it takes thought and effort and a really healthy relationship with failure. And you can be a long way from perfect and still get great results. Most of these are direct quotes from my colleague and friend called Rhys Evans, so I'm going to credit him there. Thank you very much.
Thank you a lot for your talk, and now we have some questions. First of all, if you could improve just one thing in your product, what improvement would you make?
Wow. It's a hard question because I no longer work on that product, but if I were to improve something on ft.com, it would be the observability of performance, so that new engineers who come along start caring about this in a way that the engineering team who built the thing in the first place did.
Okay, one more question. I see.
Hi there.
Hi.
You have a very large presentation, and I'm afraid I have missed it, but I've got a question regarding an end user tracking, about tracking his actions on your website. You know, there is a large amount of external services like Google Webmaster or Crazy Egg used to track end user experience on your site. So if you are so concerned about your responsiveness of your site. How do you serve this thing? I mean, do you connect, do you use some external services like Google Web Tools to analyze user experience or?
So we use SpeedCurve and we track user interactions with SpeedCurve's Lux plugin. But we run that as a canary audit, so only like on a certain percentage of traffic. We don't actually ship this third-party script to all users. And we analyze the SpeedCurve results, or at least that's what we did about half a year ago. In terms of RUM data, no, that's as far as it goes.
More questions? Any volunteers? If not, please choose the best one.
I'm gonna have to pick you. That was a really good question. Okay. Thank you.